For a more detailed naming of functional group, you can find it in Table 1 on page 9. The prefix shows which atoms or alkyl group has replaced a hydrogen in the parent chain. The prefix denotes any substituent in an organic compound and lists the positions, the numbers, and the types of substituents present. For example, in 2-chloropentanoic acid, the prefix is 2-chloro because the carbon lies in the second position and with the chlorine group acting as a substituent. This shows that one of the hydrogen atoms attached to the second carbon atom in the pentanoic acid has been replaced by a chlorine atom. The main prefixes in alphabetical order is as follows: amino, bromo, chloro, fluoro, iodo, cyano, hydroxyl, nitro, oxo, and phenol. Moving on to page 18 of the notes. When an atom from an alkane is removed, the alkane becomes an alkyl group. For example, a CH group name is known as a methyl group. In this example, we have a pentanoic acid because there is 1, 2, 3, 4, 5 carbons. It's an oric acid because it has a family from the carboxylic acid. The methyl group here acts as a side chain and it is known as a alkyl group. So it is found at the third position, hence it is 3-methyl pentanoic acid. Let's look at the rules of naming organic compound. First, you name the longest chain in the parent compound first. The chain must begin and end with a terminal carbon. Go in one direction only. The carbon needs not lie in a straight line. For example, there is a king here, a band here, so the carbon can be named 1, 2, 3, 4, 5, and 6. So this is a hexane. Let us look at the second example. The longest chain can be found here. And let's see how many carbons are there in the longest chain. 1, 2, 3, 4, 5, and 6. So the methyl group is found on the fourth carbon. But why is the naming 3-methyl-hexane? We will have to look at it because it refers to point number 2, which is the second step. When a functional group is present, the subject identifies it. Number assigned to the functional groups are chosen to be as small as possible. So in this case, instead of a 4-methyl-hexane, you numbered it the other way shown in blue. 1, 2, 3, 4, 5, 6 is still a hexane, but methyl group lies on the third carbon instead of 4 if you follow the numbering in the direction of blue, because the number assigned to the functional group must be as small as possible. Let us move on. If more than one functional group is present, the parent compound is named according to the following table of preference or precedence. First, you name the acid, followed by the aldehyde and ketone, followed by the alcohol, the alkynes, the alkenes, and then the alkane. Let us look at some example. Example number 2. Now we have a pentanol. What is a pentanol? Okay, how do we know that it's a pentanol? Let us look at the numbering system. Here we have an alcohol. So the alcohol is taken precedence over a alkane. Hence, it is not a hydroxyl alkane, but starting with an O to show that it's an alcohol. How many carbons are there in this alcohol? 1, 2, 3, 4, 5. There is a 5 carbon in this alcohol, so it is a pentanol. Where is the position of the alcohol? It is at the 4th carbon. No, you should always name the substituent with the smallest number ever. So instead of the numbers in blue, we start naming the carbon from the other position. 1, 2, 3, 4, 5. Hence is a 2-pentanol because we number the substituent with a number as small as possible on the parent chain. Let us look at 2-hydroxypentanoic acid. This is a pentanol and the family name is an acid. Acid precedes over an alcohol, so there is 5 carbon from the alcohol over the acid, starting from the acidic group. The first carbon starts from the acidic group. Hence, the OH is at the second position, and OH as a substituent is known as hydroxyl, so it's 2-hydroxypentanoic acid. Let us continue with our lecture. The third step, name the branches. The prefixes, the branches are any substituent which is joined to the parent compound. The positions of branches must be indicated by the numbers. The numbering is such as to give the branches the smallest atom number ever. Let us look at the example. For example, we have 3-methylpentanoic acid. We will name the acid group first. The numbering starts from the acidic group because acid takes precedence in this chain. 1, 2, 3, 4, 5. Hence is a pentanoic acid, and the methyl group appears on the third carbon. So it's 3-methylpentanoic acid. Let us look at example B. Here we have an alcohol and an alkyl halide or a halogenal compound. Alcohol takes precedence, so we start naming 1, 2, 3, 4, 5. So we have a 1-pentanol because the OH group appears at the first carbon. And the bromine group, the bromo group, will appear on the second carbon. Hence the naming 2-bromo 1-pentanol.